Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter electric charges and fields. So any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And in any other chapter of physics, if you have more difficulty, then please write the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. And also some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application whose link has been provided in the description. So here it is told that an electron is accelerated through a potential difference of 5.5 volt. The velocity acquired by it is. So therefore we can say that the gain in kinetic energy, the gain in kinetic energy of the electron will be equal to Q times V, where Q is the charge of the electron and V is the potential difference through which it has been accelerated. So therefore, the initial kinetic energy of the electron is zero. So suppose since y initially it suppose has started from rest. So therefore, it will be half mv square, that is equal to E into V. E is the charge of the electron. So here V is the voltage or the potential difference through which it has been accelerated, and V is the velocity. So V square is equal to 2 EV by m. So V square, that will be equal to 2 into charge of the electron 1.6 into 10 power minus 19 into the potential difference, which is 45.5, divided by m, mass of the electron, which is 9.1 into 10 power minus 31. So 9.1 will cancel out with 45.5 with 5. So this will be V square will be equal to 3.2 into 10 power 31 minus 19, which is 12. So therefore, V will be equal to uh, 2 EV by m. So it will be 2 5s are 10. So this will be 16. 16 into 10 power 12. Therefore, V will be root over this. So this will be 4 into 10 power 6. So option 1 is the correct answer. Then here it is told when a body is earth connected, electrons from the earth flow into the body. This means the body is positively charged. Since why if a body is positively charged, then only if it is being earthed, then since it has got deficiency of electrons, so electrons from the earth will flow to the body and make it neutral. So it means the body is charged positively, is charged positively. So option 2 is the correct answer. Then here it is told that a cylinder of radius r and length l is placed in a uniform. So it is a cylinder of radius r, its radius is r and the length is l, and it is placed in a uniform electric field E, which is parallel to the axis of the cylinder. Placed in an electric field which is parallel to the axis of the cylinder. The axis of the cylinder is this one. This is the axis of the cylinder. Axis of the cylinder. So then um, the total flux for the surface of the cylinder is given by. So the electric field is uniform. So therefore, the net electric flux that will be equal to E dot A at this surface, E into pi r square. And here, let's say this is the x-axis. So then be E, we, we know that flux is equal to E dot A. So this will be E into pi r square. Since by here also the electric field is along I cap only, and here also the area vector is also along I cap only. So I dot I will be +1. But here for the left surface, the area vector is along negative x-axis. So therefore it will be E into pi r square into I cap dot minus I cap. So this will become -1. So it will be E into pi r square minus pi r square. So that will become 0. So the net flux will be, the total flux for the surface of the cylinder will be 0 only. And along the curved surface, the area vector is normal to the electric field. Therefore, for the curved surface, the flux will be 0 only. So therefore, the net flux through the cylinder, the net electric flux through the cylinder will be 0. So option 3 is the correct answer. Here it is told the electric flux for the Gaussian surface A that encloses the charged particles in free spaces. Electric flux for Gaussian surface A that enclose the charged particles in free space is the net electric flux for the Gaussian surface A, that will be equal to Q enclosed, the net charge enclosed by epsilon naught. So the net charge enclosed by the Gaussian surface A that we have to find. The net charge enclosed will be Q1 plus Q2 plus Q3 divided by epsilon naught. And then Q1 will be minus 14 nanocoulomb plus 78.85 nanocoulomb, then minus 56 nanocoulomb. Nanocoulomb means into 10 power minus 9 coulomb. And epsilon naught, we can say this will be equal to, 8.85 into 10 power minus 12. So this will be equal to, so 14 plus 56, so 6, okay, so 70. So this is 8.85, 8.85 into 10 power minus 9 divided by 8.85 into 10 power minus 12. So this will be 10 power 3, 10 power 3 Newton meter square per coulomb. Okay, so charge, the flux is equal to, flux we know that is equal to electric field into area. So electric field is force per unit charge. So this is Newton per coulomb into meter square. So yeah, Newton meter square per coulomb will be the unit. So option 1 is the correct answer. Then it is told that identify the wrong statement in the following. Coulomb's law correctly describes the electric force that binds the electrons of an atom to its nucleus, binds the electrons of an atom to its nucleus, binds the protons and the electrons in the nucleus of an atom. Correctly, this, okay. binds the electrons of an atom to its nucleus, bind the atoms, okay, binds atoms and molecules to form solids. So Coulomb's law only describes the electrostatic force of attraction. So the force that binds the atoms together is not the electrostatic force. So the force that binds atoms and molecules to form solids is not the electrostatic force, and the force that binds the neutrons and protons in the nucleus is the nuclear force. It is not the electrostatic force. So only the force by which the electrons are attracted by the nucleus of an atom, that is only the electrostatic force. So Coulomb's law will describe only electrostatic force. So option 1 is the correct answer. Then here it is told that in the situation shown in the diagram, of Q, magnitude of Q, yeah, magnitude of Q is much less than magnitude of capital Q, and magnitude of and R is much greater than A. So therefore, it is acting like a dipole. The net force on the free charge minus Q and net torque on it about O at the instant shown are respectively. The net torque on it, okay. You have to find the net force on the free charge also and the net torque on it also. So therefore, the net force on it will be equal to the charge Q into E. So we can take this as the x-axis. This way is the x-axis and this way is y-axis, suppose. And O is the origin. So this way is x-axis, this way is y-axis. So then the force will be equal to the charge into the electric field at the point P. And the electric field at any point on the equatorial plane of an electric dipole is given as minus kp by r cube. Minus kp by r cube. So this will be minus k, which is 1 by 4 pi epsilon naught into p vector, which is 2aq, q into 2a into this will be I cap. Hmm. The dipole is always from minus q to plus q, so it is along I cap divided by r cube. So this is p. So therefore, so this we can write p also, and q is minus, so it is minus q. So this will be minus q into electric field, which is minus p I cap divided by 4 pi epsilon naught r cube. So this will be pq by 4 pi epsilon naught into r cube into I cap. Yep. So it means that A and D are wrong. So B and out of B and D we have to check. And the net torque will be equal to the net torque will be equal to R cross F, okay, about the point O. So this force is along the x axis. This is the force acting. So r cross f. So r cross f will be, r is like this. So r vector cross f vector will come along minus k cap. Since here r vector is r j cap. So r j cap cross f, f, the force is f I cap. So this will, j cross I is minus k. So this is r into f into minus k cap. So this will be r into this. So pq by 4 pi epsilon naught r square into minus k cap. So option C is the correct answer. Then here it has been told that a positively charged glass rod, a positively charged glass rod is brought near an uncharged metal sphere, which is mounted on an insulated stand. It is a metal sphere which is uncharged. So it is a conductor. It is a conductor since why it is made up of metal. So if the glass rod is removed, the net charge on the metal sphere. So since here no charge is being formed, so when the glass rod is removed, the net charge on the m- metal sphere will remain zero only. So when the glass rod is brought near it, so then some negative charge will be formed on that side which is close to the glass rod, and on the opposite side an equal amount of positive charge will be formed. Since why, on this side we will have some excess of electrons, and on the opposite side we will have same amount of deficiency of electrons, same amount of deficiency of electrons. So here and here some charges will be formed, although the net charge on the sphere will be zero only. Net charge will be zero only, and when the glass rod is removed, so then these charges will also uh, will be removed. So then also the net charge will remain as zero only. So option D is the correct answer. Then here it is told that a cubical Gaussian surface has a side of length A which is 10 centimeter. Electric field lines are parallel to x-axis as shown. The magnitude of electric fields to surfaces A, C, A, B, C, D, and E, F, G, H are 9, 6 kilonewton per coulomb and 9 kilonewton per coulomb respectively. Then the total charge enclosed by the cube is, take epsilon is not is equal to 9 into 10 power minus 12 uh, farad per meter. The unit of epsilon naught is farad per meter, since we know that C is equal to, we know that epsilon naught A by D, which is called capacitance. So epsilon naught, the unit for capacitance is farad. So epsilon naught unit will be farad per m- meter. Since why, the unit of area is meter square and the unit of D is meter. So the unit of epsilon naught will be farad per meter. Then here we know that the the net flux through the Gaussian surface is equal to the net charge enclosed by epsilon naught. So then here the net charge enclosed will be equal to epsilon naught into the net flux. epsilon naught is 9 into 10 power minus 12, and the net flux will be, uh, so here it will be E into A. The flux through the first surface, here we can call it, on this surface EFGH, the net flux phi 1 will be E dot A. So here the area vector is also along I cap only, and the electric field is also along I cap. So here on this surface, the flux will be positive, E into A. But on the other side, means on the surface ABCD, the flux phi 2 will be negative. Since why here the area vector is along the negative x-axis, means along minus I cap, the area vector is along negative I cap, and the electric field is along positive I cap. So E dot A, if you do, then it will come minus E2 into A. So here it will be plus E1 into A. So here the electric field is 9 kilonewton, so 9 into 10 power 3 into area, which is side length is 10 centimeters, so it is A square, since it is a square. Each each face is a square, since it is a cubical Gaussian surface. So it is 100 centimeter square. So 100 into 1 centimeter square is 10 power minus 4 meter square. So this will be 10 power 5. So this will be equal to 90 Newton meter square per coulomb. And here phi 2 will be equal to minus of E1, which is 6 into 10 power minus 6 into 10 power 3, 6 kilonewton, into area. Area is again 100 into 10 power minus 4. So this will be minus 60 Newton meter square per coulomb. So therefore the net flux will be phi 1 plus phi 2. That will be 90 minus 60, that is 30 Newton meter square per coulomb. So this into phi net, which is into 30. This much coulomb is the net charge. So therefore it is 327, so 270, or I can say 2.7 into 10 power minus 10 coulomb, or I can say will be 0.27 nanocoulomb. 0.27 nanocoulomb. So option B is the correct answer. Then here it is told the electric field at a distance r from an infinitely long charged straight conductor having linear charge density lambda is E1. Here one charged rod is there. Its net linear charge density is lambda, and at a distance r, the electric field is E1. Another uniformly charged conductor having same linear charge density lambda is bent into a semicircle. It is bent into a semicircle. The electric field at its center will be E2. Electric field at its center is E2. So then what will be the relation in between E1 and E2? So E1 will be equal to, we know that it is 2k lambda by r, where k is equal to 1 by 4 pi epsilon naught, with 2k lambda by r, and E2 also it will be 2k lambda by r. So it means that E1 will be equal to E2. So it means option A is the correct answer. Yep. Then here it is told a copper rod AB of length L, a copper rod AB is a copper rod AB of length L is rotated about its end A, is rotated about its end A with a constant angular velocity omega, the electric field at a distance x from the axis of rotation is. So here we can assume one electron. So it will, so here actually some positive charge will be formed, and here since some excess of electrons will be there at the end B, so here some negative charge will be formed. So the one electric field will be formed like this, means towards the, so no, some electric field will be formed away from the center, away from the center. So then the electric field at a distance x, this we have to find. So if the electric field at a point x is E, then we can say that the force on this electron, the centripetal force on the electron will be equal to the net electrostatic force. So the centripetal force will be equal to m omega square x, and that will be equal to the electrostatic force, which is E into E. So therefore, the electric field will be equal to m omega square x by E. So it means that option A is the correct answer. Then here it is told electric field due to an infinite straight uniformly charged where varies with distance r as. Electric field due to, okay, electric field due to an infinite straight uniformly charged where varies with r as. It is an infinitely long where. So the electric field will be equal to 2k lambda by r. So the electric field varies inversely with r. So option B is the correct answer. Then here it is told a 2-gram object located in a region. It is a 2-gram object. It is located in a region of uniform electric field. Uniform electric field equal to 300 Newton per Coulomb I cap. It carries a charge q. The object is released from rest. The object is released from rest at x equal to 0. Here the initial velocity is 0, and it has a kinetic energy. It has kinetic energy of 0.12 joule at x equal to 0.5 meters. Then the charge q is how much? So the mass is 2 kg. So I can say it is 2 into 10 power minus 3. 2 gram means 2 into 10 power minus 3 kg. So therefore, we can say that the work done by the electric field, that will be equal to the gain in kinetic energy. Work done by the electric field, that is equal to the gain in kinetic energy, which is half mv square, which is the fin, final kinetic energy, minus the initial kinetic energy. So here, since the initial velocity is 0, so the initial kinetic energy will be 0 only. So therefore, work done by the electric field will be equal to the q into E, which is the electric force, into the distance, which is 0.5. So that will be equal to final kinetic energy, which is 0.12 joule. So therefore, q into 300, okay, 0.5 is equal to 0.12. 0.5, it means that it is half. Half means 150. So therefore, the charge q is equal to 0.12 divided by 150. This much coulomb. So therefore, the answer is given in microcoulomb. So I can say this is 0.12 by 150 into 10 power 6. So 1000 into 1000 microcoulomb. So this will be 120 into 1000 by 150 microcoulomb. So this will be 0 will cancel, 4 3 so 3 4s are 12, 3 5s are 15, 5 2s are 10. So this is 800 microcoulomb. So it means option C is the correct answer. And since it is going towards the positive x-axis and the electric field is also along the positive x-axis only, so the charge is a positive charge. It should be a positive charge only. So it should be plus 800 microcoulomb. So option C is the answer. Then here it has been told, okay. So here, okay. So here we can end the uh, this video on the solutions of the previous year KCET questions on the electric field. In the next part, we shall solve the remaining questions. And so till here, any doubts if you have, then please write that in the comments. We shall obviously clarify them in the subsequent videos. And please install our Sapience education application also, where we shall upload some important homework questions based on the previous year KCET exam, which shall be helpful for your exam. So thank you everyone. Bye.